This video lesson is on VES. It's the VES of drives. So I'll put up the definitions again. The previous video covers domain, range, and intercept, so I'll start here. The V in drive stands for variation. That has to do with where the function is increasing, decreasing, or constant. And all of those answers are listed in terms of the x values. So you're going to give an interval in terms of x values that describes the beginning point and the end point of the interval where the function is increasing or decreasing or constant. And we'll talk about what the difference is between increasing, decreasing, and strictly increasing, decreasing. Extrema, the E is the minimum and or the maximum y value. So that's the min and the max. And sign refers to the x values where the function is positive or negative, or strictly positive or strictly negative. So we'll go through those. Increasing is, again, the x values over which the function is increasing. And increasing, as opposed to strictly increasing, includes constant segments that are attached towards increasing or decreasing. So this function increases in this segment and this segment. And because both of those segments have a flat or constant part attached to it, I write those intervals this way. So from 0 all the way to the end of this one and this interval. And because they're connected, I write it all as one interval from 0 to 50. The rule for increasing is that almost always the endpoints will be excluded. The only time you'll have included endpoints in increasing or decreasing is if you have a curved segment. Otherwise, always excluding. And for strictly increasing and strictly decreasing, they're just always, always, always excluded. That's it. So that's the increasing segment. And decreasing is, oh, sorry, this is another increasing example. Sorry, if you want to pause here for a minute and check it out, see if you can write the answer. Remember that curved endpoints are included for increasing. So if you want to pause and try to write out this interval where this is increasing, there are, here's the answer. You can, hopefully you've unpaused now if you tried it on your own. There are 3 segments, and this is how they are listed. Now the first part has an excluding endpoint, and the last one has an excluding endpoint because we don't know what's happening after that. It might stop sharply, it might not continue in a curved way. But this one, which we know is curved, and this one, and this one, and this one, those ones are all included. So basically the endpoints of a graph are going to be excluded, and only in increasing or decreasing, if you have a clearly fully curved endpoint, is it included. And I included units because they were included there. Okay, and that union is for whenever you have more than one segment that's separated. So this one, there's space between the next segment, and there's space between the segment after that. Okay, so if you want to try these, you can pause again for a second, see if you can get the answers. The answer here increases from 7 to 10. 7's included, and this one has 3 segments. Again, the endpoints of the graph here not included. This one has an arrow, which means it continues to infinity. That's never included. And these ones here, 1, 2, 3, and 4, are all included because they're curved. Decreasing works exactly the same way. So flat bits, if they're attached to where it's decreasing, are included. This part here is decreasing, and there's a flat part before it, so that interval is the decreasing, both excluded, this one being the end of a graph, this one not being curved. I included units because they were in the graph. And if you want to try this one too, this again is going to have multiple regions where it's decreasing. If you want to pause and give it a try, the decreasing intervals here are this segment and this segment. Both of those are going to have included because there is no beginning or end of the graph. Those are just curved endpoints. So that's the answer there. And a couple of others if you want to try them. So if you want to pause and give it a try, this one decreases from 0 to 7, 0 excluded because it's the start of the graph. And here from 0 to 9, both excluded because there are no curves. Constant is just the flat bits, and constant segments will always be excluded. And in the case of a curve, you would include just the point at the very top or the very bottom of the curve. So in this case, where is this function constant? It's only at those points that change. And so there's one here, 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 and here. Those points are all constant, and they're in squiggly brackets because it's not between those points. It's just those points themselves. So again, the difference between increasing and strictly increasing is 1. Increasing can include flat or constant parts if they're attached. Strictly does not. And so the endpoints will never, ever be included, because the endpoints could only be included if it was a curved segment and then that point itself was considered constant. Here we don't include any constant stuff. So I would have a very similar answer to what I had before, except that all of the endpoints now are excluded. And in a case like this, my increasing parts, I would have 2 of them, both endpoints would be included, and they would not include the flat parts attached, whereas the other one did. That's strictly increasing, and strictly decreasing works the same way. So here my endpoints would be excluded, and here my decreasing segment would not, my strictly decreasing segment would not include that flat portion before. Extrema is maximum and minimum values. They are y values. And if the function goes to infinity, you write your answer as none. So, here the max value is the y value that's the highest one achieved, 110. And in this case, you'd say none, because this arrow will continue upwards forever. And minimum is the same idea. It's the lowest possible y value. This one has a minimum of -2. It's the lowest y value. This one, 0. And if it went down to negative infinity, you would write that there's none. And finally, for sine, it's the set of x values where the function is positive when you're talking about positive. So the function is actually positive in this region here and this region here. And when I write out my answers, that's from 0 to 5, union from 8.5 here until 10. It's a bit of an approximation, but that's the best we can do here. And in this case, if you want to pause and give it a try, this function is positive in a bunch of places, from -12 to -10, then also from here to here, then also from here to here. And this one is positive its entire domain. And negative is the exact same thing, but below the axis. It includes all the points where the function is 0, so those parts are included. If you want to give these ones a try, you can pause for a second and write it out. In this case, I would say just the actual point 9. It's weird, but I'm looking for where the function is equal to or below. And here it's not below, but it is equal to, so I include that 1 point. And strictly positive and strictly negative don't include the points where the function is 0. So it doesn't mean that all endpoints change, but the endpoints where the function had been 0. So at 0, my function is fully positive, but over here at 5, that's where the function is equal to 0. That's excluded. Same for 8.5, excluded. And if you want to give these, there's one more example before you try. Negative and strictly negative, the difference is that the endpoints are excluded. The points where the function is 0 are not included. So in this case, these 2 endpoints are excluded. And if you want to try a full example, you can pause and go through the domain range, increasing, decreasing, positive, and negative for this function. Give it a try and see if you were correct. And the other things that weren't the first one, if you want to, again, pause and give it a try. Some of these were already seen, but not necessarily all of them. And one more, if you want to pause and give it a try, see if you know how to answer these. Increasing, decreasing. And the strictly's, if you want to give them a try, you can pause and check your answer. That concludes drives.